Thank you everybody for joining. I will run a little bit through the workshop agenda of today. So I will start with the introduction to the refresh project, and then I will basically leave the floor to our technical partners to present their technologies that are involved in our project. So we will start with the smart blade cutting from Etat 9, the shredding and sorting technologies from TB, the mechanical recycling technologies from GIS Recycling, the advanced thermal recycling from Gencraft, the microwave assisted pyrolysis from CIRSE, the thermochemical treatment of dust and fines from an Ecolab. Lastly, the regulatory challenges for the blade circularity from EUSIA. And then we will have at the end the Q&A session. So you will just put your questions in the comments or in the chat. I don't know if, in the comments. So we will answer those questions at the end of the sessions. So we'll start now from the quick overview of the project. So the refresh project, which it's about the recycling of the wind blades, and we have a consortium which is located in Europe, and we have waste recycling and remanufacturing companies. We have engineering consulting companies, research and development companies. Then we have the dissemination and the communication parts that grants us the access to the stakeholders in the composite sector manufacturers from with the EUSIA part, and it's coordinated by RINA Consulting. So quick overview of the methodology of the project. So the concept is that we decommission the wind blades. From the decommissioning till the new end product, refresh is covering the whole secondary value chain. So we decommission the wind blades, and then there is the pre-treatment, and then the treated wind blades are sent to the different recycling processes. So the mechanical recycling, the thermochemical recycling, because every process gives us a new end product. Because this was the challenge number one when trying to recycle the wind blades, because if you try to just recover the material, it's a problem, because the virgin raw material is much more cheaper of the recycled ones. So we need to add an added value, and that's why we opted for producing new end product from the recycling chain. Everything from here is managed, and every decommissioned wind blade pre-treated is then sent to the proper recycling process with a market check, a technical check, an environmental check, which is performed by a traceability and decision-making tool, which is deployed also in the framework of this project. So this is practically the digital brain of the whole process. So it gives us real-time tracking, information sharing, which is transparent because it takes it keeps trace of the data that are from the composition, the technical condition, everything of that wind blade, which gains the data through the whole value chain. So the quality control is obviously enhanced, the efficiency and the secondary material acceptance are increased, and also we grant the regulatory compliance. So this can give us a digital passport, basically, of each product is exiting the refresh value chain. So speaking about the refresh value chain, we have here the conceptual map of who is doing what. So as I said before, we're starting from the decommissioned wind blade. So the first step of the pre-treatment is from Etat 9 and MTB. And then we have either the repurposing of the wind blade after the first treatment, or either the recycling processes, the mechanical recycling and the thermal recycling processes, which give us some secondary products. For example, composite panels, we can recover fibers, we can recover chemicals from the epoxy resin matrix with the thermal treatments, and also we can recover energy with the dust and fines gasification process. And also there are the Setma, Tecnali, and Acciona, which are working the eco design. So we take those secondary product, and then we can finish the value chain by transform those products in end product like construction panel, urban furniture, or a 3D cement. And also other wind turbine components of second generation. So the eco design strategy here in the refresh project basically is it's all about the repurposing and the recycling. We have some examples that I have already cited before. So the formwork panels, something like from the repurposing, and also the 3D printed cement. These are some images of what I were talking about before. And those are some results from the sustainability analysis, the preliminary LCA results. So each project, each process was analyzed, and it shows every process here shows a lot of CO2 equivalent, which can be saved. And those are the preliminary LCA results. We will have the final one once the deployment phase is fully completed. To give you an idea on the timeline of the project, so we have from month 1, month 18, the project started on the 1st January of 2023. So we are currently at month 35. So the first phase was like the design phase, in which the process and plans were designed, and also the preliminary LCA was carried out. So we had to run through the go-no-go milestones, which was a go, and now we've been working in the integration testing phase with the experimental LCA and also the traceability platform, which will be made operative. So we are missing like 1 year of project basically. So okay. Okay, this was my introduction.